Welcome back. Continuing on our lecture 5, nested loops. You can have a for loop within a for loop. Okay, that's a nested loop. You could have for loop, for loop, for loop, continuing. All right. Finite number. The technique of using one control structure within the body of another is called nesting. So let's go through this. For chapters so chapter is an identifier in the tuple. Notice we haven't used list. It's a tuple. 1, 2. These are strings. Colon, print, chapter, space. Concatenate, whatever string you choose. So 1. So suppose you are in chapter 1. The body of this for loop also includes another loop for section in string A, string B, string C. That's the inner loop. Print, section with a space. Aha, that's a typo. If I'm opening with single quote, I must close with single quote. Concatenate, chapter. Remember chapter? Concatenate, section. After completing this print, you are done with section A. Then go to section B. Then go to section C. You are done with the for loop for chapter 1. Then you go to chapter 2 and go through this entire thing. Then you are completely done with for loop, the first for loop, and then you would say print appendix. Let's write all that down. I will simply erase the previous codes. Okay, I don't need it anymore. For chapter in string 1, string 2, that's my outer loop. Print string chapter with a space plus little chapter. So the little one is the identifier which is going through that tuple. Within the outer loop, I have an inner loop for section in tuple string A, string B, string C. Don't forget colon. That's your inner loop. Print section space, close that in quote, single quote, plus. So that plus is a concatenation, chapter plus section, close your parentheses. Get out of this inner loop, get out of the outer loop, and now say print appendix. Okay, you may have noticed hash outer loop. What happens if I write a hash here? Well, nothing different from, notice how it became red in color. Hash means comment it out. Okay, so this will not be compiled. It will not be bothered by the compiler. So likewise here, hash inner loop. It will not bother my compiler, but it is a useful thing for us to, the programmer, to understand what's going on. Okay, so I'll control S for save or command S for save, and now run it. Chapter 1, section 1A, section 1B, section 1C. That took care of the inner loop. And then you're on chapter 2. That's the outer loop again. Section 2a, section 2b, section 2c. We are done with the inner loop. We are done with the outer loop because we did both chapter 1 and chapter 2. Finally, you can say print. Now, if this appendix print were indented, let's see what happens. If I indent it once, so it's aligned here, run it, save, and then run it. You see how appendix showed up after chapter 1? Appendix showed up after chapter 2 because it was indented in the body of the outer one. Suppose I indent it once more. So now it is in the body of the inner one. One A appendix, 1B appendix, 1C appendix, 2A. Sorry about that. So you see, indentation makes it run again and again. All right. So here is another way of using for loop in list comprehension. Auxiliary is empty list. For person and guess, remember guess, append that person but lower him first. That is, consider the lower case, append in your auxiliary. Okay, so this is a standard way of using. So let me erase all of this. As of now, because I'm writing a new file, they don't know who guests are. So guests are Carol, Alice, Bob. Auxiliary equals empty list for person in guess. Take your auxiliary list, append it. So append is the method of the auxiliary object. Take your person, that will be a string, lower it, lowercase it, and put that in auxiliary. Okay, now print auxiliary, save, run. Look at that. My auxiliary was initially an empty list. I've taken every one of these names and converted them to lowercase and appended them here. Okay. At this point, I want to tell you what auxiliary here is. You start with something and then you improve it, right? So we have seen this phenomenon earlier in the transactions example. Here, balance is 0. To begin with, it's 0, and then you kept updating it, adding to it. All right. It is the same notion here. You started with something empty and that then kept improving it. Such a variable is called an accumulator. So you're accumulating information in here. Accumulator is a very useful approach in for loops. All right. So this is an important use of accumulator. All right. So that was the nested loop example. Now, this is an accumulator approach. We start with an empty list and then populate it using a loop. Now, there is a simpler syntax for this precise same loop. Okay. I will start with, let me get rid of this, auxiliary be the empty list, and I'm now going to use a for loop within the list. I'm going to place person.lower in the list for person in guess. So my guesses are the same. Instead of writing the for loop outside and appending inside, this is called list comprehension. I throw in the for loop inside and then work with it. So put whatever you want to put first for person and guess. You see? Save, run. Oh, I forgot to print. Save, run. So notice I get the same result. Okay, I get the same output. Now, so here was an example of what is called list comprehension. List comprehension result is write down expression you want for identifier in sequence. Okay. Expression for identifier in sequence. Okay. If, with an if condition. That's a beautiful one. Let's look at the transactions example. Okay. Transactions equals 200 minus 50, 100. Okay. Now, deposits is the list entry for entry in transactions if entry greater than 0. So what am I going to do? I'm going to consider only those numbers which are greater than 0. So 200 and 100. Save. Oh, don't forget to print deposits. So what happened to deposits? I got 200 and 100, exactly as I expected, right? So suppose I say I change my transactions, okay? Minus 300, 0, 500, 1000. These are various deposits, right, in your bank. Now, instead of if entry is greater than 0, I'll say less than 0. Save, run. So you see, I got only the negatives from left to right. But this entry does not have to be this simple. So say, I say 2 times the entry plus 10. Okay. So I want to get this expression evaluated within my list, within building my list, right? So let's see. 2 times this minus 10. Plus 10. 2 times this plus 10. 2 times this plus 10. Suppose I do the positive version. Okay. So 2 times the positive number plus 10. 2 times the positive number plus 10. 2 times the positive number plus 10. Now suppose I don't want any of these. Suppose I want to write down this expression for everything in my transactions. So 2 times my entry plus 10 and so on. Okay. So this is a very good use of list comprehension. Everything gets done in one line. Okay. So that completes lecture 5. We'll see you in the next lecture. Okay. Until then.